Okay, next we're going to be talking about dividing fractions. But before we do that, let's talk about the reciprocal of a fraction. So let's talk about reciprocals. And basically, it's flipping a fraction. Right, so what was in the numerator goes to the denominator, what was in the denominator goes to the numerator. So the formal definition is that two numbers are reciprocals if their product again, remember, is multiplication, is 1. Okay, so for example, 8/3 and 3/8 are reciprocals because 8/3 times 3/8, right, which is 24/24, any number over itself is 1. Okay, so to find the reciprocal of any non-zero, meaning it can't be 0, okay, any fraction other than 0, all we have to do is swap the numerator and the denominator. Okay, so let's do a couple examples. So if I'm given, give me my original fraction, and then let's see what the reciprocal is. All right, let's see. So my original fraction is 2/5. All I had to do is flip my numerator and denominator, and I get 5/2. Right. What if I gave you 1/9? And I flip it, I get 9/1, which actually just simplifies to 9. What if I just give you a whole number? Well, a whole number, remember, a whole number is the same as that whole number over 1, right? Any number over 1. So now that looks like a fraction again. And now if I flip it, it just goes to 1/5. Same thing with the negative. Don't worry about the fact that it's negative. The reciprocal stays the same sign. It's still negative, and I just flip the fraction. In the special case, though, is if I give you 0, right? I can't flip 0, so this is undefined. Okay, so now we've talked about reciprocals of fractions. We can move into dividing fractions. Okay, so dividing fractions is just, we basically change the division operation into multiplication, but we multiply it by the reciprocal of the second fraction. So to divide two fractions, we simply multiply the first fraction, which we call the dividend, multiply the reciprocal of the second fraction, which we call the divisor. Right, so basically what we're doing is we're changing the division problem into a multiplication. So let's say I have a fraction a over b, and I want to divide it by the fraction c over d. All I do now is I keep the first fraction, right? I change the sign, I change the operation to a multiplication, and then I flip the second fraction, so it's just d over c. Okay, so this is the division, right? Division problem, and I'm going to, this one stays the same, this fraction stays the same. Right? I change this to multiplication. And then I flip this fraction. And then you just multiply. Okay, let's do a couple examples. Let's say I ask you to divide 2/5 divided by 7/4. Okay, this stays the same, so it's still 2/5. Right. This changes to a multiplication. Then this changes, and I flip it. So this becomes 4/7. Right? So I flip the second, and I change the operation to a multiplication. And now I can simply multiply across. So I get 2 times 4 over 5 times 7, which is 8 over 35. Okay. If I had 2 over 27 divided by -8 over 15. First off, it's a positive divided by a negative, right? So I'm going to remind myself that my answer is negative. So you got to remember that, okay? And then it's just the normal, it's just a normal problem now, as long as we remember what our answer is going to be. So it's 2 over 27. That stays the same. Change it to a multiplication and flip the second. 15 over 8, right? Negative. And again, I can look for common factors. So I have 2 times 3 times 5 is 15. Right, 27 is 3 times 9, or 3 times 3 times 3. And then 8 is 2 times 2 times 2. Right. So I can figure out what I can cancel. I have my 3's, one of them can cancel. One of the 2's can cancel. So I have negative. Remember, my answer is going to be negative. I still have a 5 in the numerator. And if I multiply this out here, I have 9 times 4, which is 36. So my answer is -5/36. Okay, alternatively, we could have done this, right? 2 times 27, 15 over 8. And again, I know my answer is going to be negative, right? So I'm just going to put a negative out there. I can start to think about what are some of the common factors. I notice that 2 and 8 share a common factor. 2 goes into 2 1 time, 2 goes into 8 4 times. If I look at 15 and 27, I notice that they also have a common factor, right? 3 goes into both of them. So 3 goes into 15 5 times, 3 goes into 27 9 times. So now if I multiply across, I get 1 times 5, 9 times 4, so I have 5 over 36, and the answer is negative. So if you start seeing common factors like that, you can make your life a lot simpler just by reducing. Let's do another example. I'll say divide 35/14 divided by 7. Okay, again, so let's remind ourselves, this is the same as 35/14 divided by, right, this is the same as 7/1. Okay, now we change it to multiplication. So change to multiplication. So I have this first one stays the same. I change it to multiplication. The reciprocal of 7 is just 1/7. Whoops, I should have made that. Sorry. This should be 14. Okay, so let's see if we have any common factors. Well, I know 7 goes into 7 one time, and 7 goes into 35 5 times. So now I don't have any more common factors, so I can multiply out through, and I get 5/14. Okay, so basically division is just is an extension of the multiplication process. You have to take the reciprocal of the second, which is the divisor, and then make it a multiplication problem.